right, getting started into our next presenter, we have Phil Lewis with the USDA.
Good morning, everyone. Appreciate the opportunity to present some of my research. I work at the Forest Pest Methods Lab along with Stephen, and our laboratory kind of provides support, research support for the various PPQ programs, forest pests, and other things. And my normal duties, I'm presenting on this amazing trap that we've been developing. And my normal duties are pesticides. And usually it's like Matt or Greg call me up. How do we kill this thing? What do we do for this pest? But this was like a side project that my group got involved in, just kind of a interest in how do they lay their eggs? Where do they lay their eggs? How can we work with that and find a way to get them to lay eggs where we want them to? So this is a trap. We call it a lampshade trap. It's made from a roll of roofing material. So you can see the bottom layer you've attached to the tree. The same material is then inverted. You see the white film there. It's covering the adhesive. So that's inverted, and then it just it's a passive trap. They'll crawl up and down the tree like they normally do, and they'll lay their eggs in it. So the first year we first set these out in the late summer of 2022. And then once they started laying eggs, we saw that they were actually in there. We could look inside the trap. You can see there's a small gap so they can crawl in and out. And so that was a good indication that we had something that would work. I want to introduce my group here. Amanda's at the top. Emily Wallace, which actually it's her birthday. She's one of these February 29th birthday people, only has a handful of real birthdays in her life, but shout out to Emily. Happy birthday. And then Melissa, she started out working as a summer technician for us, but since we got the results and developed the trap, we published a paper last spring. And then I asked Emily and Melissa to create a short YouTube video. If you need any of those links, just email me and I'll send them off to you. Just an instructional video, her actually attaching the trap, how to do it. And then we also have a 2-page resource for pictures and instructions on how to make the traps and a list of materials with links so you can buy everything that you need for it. So purpose, really looking at population detection, assessments, trap and remove. A lot of our PPQ offices and state people are out there scraping egg masses, and they really concentrate their eggs within these traps. So why not put these out and assist with that effort? So a little trip down memory lane. I want to take you back. It's been 5 years since we've been working on these traps, and just some of the situations that people that work out in the field know that, they tend to lay clusters of eggs sometimes in certain environments, not always. A tree like this, it's kind of leaning. It's kind of a protected area at the base of the tree. They'll lay clusters there. And so one of the first attempts we did was to put some burlap and wrap a tree and see if they would lay their eggs in or on that material. And sure enough, we had some egg masses there. This was exciting. There were some horizontal fallen trees in our plots. And so we just draped some burlap over these trees. And when we went to assess it, they're like 15, 20 egg masses here. So that was pretty exciting. Like, well, but could we replicate that? Not really, but it happened. Many of you have seen clusters along edges of the trees like this. So, well, why is that? Well, you can see we had a rain event and the rest of the tree is soaked, but the tree was leaning a little bit. And so you get these clusters of egg masses. Maybe they're laying them there to keep them dry. I don't know. Just another indication, like these little things that were out there that the lanternflies are doing. Some other inspirations. There was a 55-gallon metal lid, rusty metal lid in the woods that somebody had tossed in there. Who knows? So there's all kinds of weird stuff in the woods sometimes. This was leaning against a tree. We turned it over, and they had laid a whole bunch of eggs on there. They like rusty metal. Or you harvest egg masses and you go back a year later, they lay their eggs within that little niche. One of the traps that we tested was to kind of create the same environment. And then we used cork as a backing and then also the asphalt material. That didn't work. We also decided we'd have these little tube hotels. Who wouldn't want to lay their eggs in a little tube hotel? Had like 4 little dryer vent pieces and we've had a tarp over it. And that didn't work. And so we're just throwing out everything. We did pleated fabrics, we did rusty metal, we did sandwich pieces of metal so that they could crawl in there, lay their eggs. We covered the pleated material with the burlap fabric. We pleated the burlap. This one Amanda calls the starfish formation. So these are half pipes, kind of intercept them as they're crawling up the tree. And they like the rusty metal. We found a way you can go on the internet and find out how to rust metal chemically. So we did that. And then, we would put the half pipes on the tree and then half pipes with burlap hanging over, try to replicate that first, find that we had with that fallen tree. And sure enough, we'd see lanternflies crawling around our trapping surfaces. That was exciting. But you can see for our total numbers of eggs in all our different traps, over 500 over these 4 years, just very few. But we did, each year we would find like a little breadcrumb. They would leave us like, oh, they like this or they will do that. So we weren't totally discouraged, but mostly discouraged and just nothing's really working until 2021. And this is some of the material. So this is the roofing material. We put it as a straight layer, and then we'd also have these sections because we thought, well, they like to go underneath things, protected areas. Maybe they'll lay their eggs underneath the shingled areas. So this surface material is gaffing tape. And then we also were trying covered and uncovered of those traps. And then this is cork material, which really didn't work well. It started to warp over time in the weather. Wasn't really good. So again, no statistical significance because we weren't catching enough eggs to really show that we were catching them until that last year in 2021. And in that year, we kind of identified that by turning the material inward instead of, this is the year before, we had it all outside and we found very few, actually 7. You could see in 2020, we only had 7 egg masses for all our hundreds of traps that we put out. But by turning it inward and then having traps that were covered with the lid, then we had our significance because of the number of egg masses that we're able to catch. So this is that setup in 2021. We had 2 different heights. We did base and then kind of working height, chest height. And there was no difference between the heights. So, okay, so we don't have to get on the ground on our knees and set up a trap, just work at a convenient height. And then we also saw that it was significant that the covered environment for the traps was significant. And you can see the eggs were inside the asphalt material on the inside of the traps. Unfortunately, we can only average 3 to 5 egg masses. So that's not worth anybody's effort to create these traps and put them out. So that was discouraging. So we thought we're going to do one last approach. They'll lay their eggs on the asphalt material and we'll just, so 2022, we just set up this one trap. We thought if this doesn't work, we're done. We're not going to mess with it anymore. Like I said, it's just kind of a little interest that we had, a little side project that we put out these traps each year. The roofing material comes in a roll. It's used by roofers just above the drip line. So it has an adhesive on the back of it. It's kind of the first layer and then the shingles go on top of it. So you can buy it at any home goods store, home improvement store. Comes in a 33-foot roll. So we put that around the tree, staple it on there, put a couple of zip ties, and the batting material you see there is just to hold the second layer away. And so Emily called it The lampshade trap would like to keep a couple of inch gap so that they can come in and out. So as far as costs go, the shingle material, like I said, comes in a 30-foot roll, $28. If we take our average tree, I'll show you in a little bit, but the good kind of the sweet spot for the size of tree that you need is a 6 to 8 inch tree. So if we assume we're putting these traps on a 7-inch tree, you can get about 8 trees or 8 traps set out on trees, and that's about $3.50 per trap. And then in addition to that, you need to invest in basic stuff like a staple gun, box cutter, and a DBH tape so you can measure your trees. We do a couple of zip ties at the bottom and at the top. The batting material is secured with a zip tie at the top, like I said, so that kind of holds the lampshade portion of the trap away so that there's that gap there. So altogether, we're talking just $5 per trap, but you do have to build it. Not complicated or hard, but you can't just buy it like a circle trap and just tack it up. Takes us 5 to 7 minutes for experienced people. It's always nice to have 2 people putting out the traps. So about a year ago, we took down the traps that we set up in 2022. For that study, we had 104 traps, deployed those end of September, and a month later, end of October. And we had 5 sites in Pennsylvania, and then Emily with PPQ in Delaware, we had a site at her location, and these are the results that we had from the paper. We had put out a portion of the traps on horizontal trees that were in our woodlots. It's really interesting, the same environment, they hardly would lay any eggs if it was a horizontal orientation. And you can see, depending on the 6 different sites, we range from 10 up to, we had a couple sites around 50 egg masses average per trap. So that was very encouraging. Looking at total number of egg masses based on the size of trees that we put out. So we had the smaller trees, 4 to 5 inches up to 13 inches. There was really no statistical difference between the larger 2 size classes. But when we convert the area of the trap, so the bigger traps obviously have a bigger area, but they actually caught on average fewer. So kind of the sweet spot for the traps is the 6 to 8 inch. You could certainly put it on bigger trees or smaller trees, but you're probably not going to get as much production out of that per trapping area. The other aspect too is that these larger trees, it takes a lot more material. It's a little bit more cumbersome to attach the traps to the trees, and they don't really set as well just because of the weight of the material. So we're just recommending just the normal trees that you would encounter, 6 to 8. You can certainly go smaller than that. You're just not going to get as many eggs because there's just less trapping material out there. So this is during harvest. You can see we took the traps off. This is about a year ago, and we just had a couple of the traps had over 100 egg masses for after just a couple months in the field, late September. So that was exciting. I've been promoting this for a while. I dressed up as a lampshade trap for Halloween at the lab. People were kind of like looking underneath, looking, where's the egg masses? Like, no, I didn't put any egg masses on me, but so just to summarize from the work that we did last year, based on the control trees, we had matching control trees, and we counted how many egg masses were on the trees from the base up to 10 foot high, compared to what was within the traps on a square foot basis. We had 100 to 300 times more egg masses on our traps than in the surrounding environment. So they greatly prefer to lay their eggs within these traps. It's low cost, just takes several minutes to deploy these in the field. You could set these up. I've been talking to various people because we set these up in September, October. You could set these up, this very durable material, obviously roofing material. You could set this up in June or July and then just keep them out there till they're ready to go and the eggs are being laid. We repeated some of this work this year as well, and just now getting that data in, but we're again seeing an average of 50 or more on average per trap. And these are in medium to high lanternfly populations. Current projects, we're working with our laboratory and doing a cold storage study because the biocontrol group likes to have egg masses. And this would be a real convenient way to collect them and have them. So we, a couple weeks ago, we harvested just normal bark harvested. We're going to compare those to our trap egg masses on our traps and do cold storage for 0, 1, 3, and 6 months just to see if over time, if there's any concerns about viability. We did notice the first year there was some surface fungal growth on the traps within our egg mass traps. So we looked at that this year to try to mitigate that a little bit so that there wasn't so much. This year it was a lot lighter than last year. We didn't see as much fungal growth, so maybe it was just the previous year's conditions. It was more wet or more rain events, something like that. But in fact, as we looked at the data, we didn't see really any impact on hatch. There's some surface fungal growth, but we're not seeing an impact on hatch. And also when we use the material, the roofing material, we don't have the problems that we have like with bark collected material, and you're trying to store that. You have all the fungus and stuff that's already on the bark that's creating problems for storage. And we don't see that with our material. So for this year, I'll show you some data, but we had over 200 traps. I kind of collaborated with a bunch of PPQ people throughout 6 different states, putting these traps out. And we also treated and didn't treat, but we put traps on non-preferred host trees. So I'll show you that data. So let me describe this graph. This is from this year's data. This is Connecticut, Delaware, New York, and then our 4 research sites in Pennsylvania that I have right now. So in blue are the averages. So each of these blue bars is made up of at least 9 Tree of Heaven traps that were deployed. Some sites we had 2 replications, so we had 18. But for each of these averages, that's at least 9 traps. So you could see we had a range of 25 up to this site was like 85 average per trap. So they worked phenomenally well. We also were interested because we had seen last year that they tend to prefer laying their eggs on the outer layer, on the lampshade portion. So you can see that here. Sometimes it's not a statistically significant difference, but there's definitely a trend. Sometimes it is statistical at a certain site that they will lay more eggs on the outer portion of the trap. We also, like I mentioned, looked at other tree species. My next slide, I'll show that. So in comparison to all these numbers that we were generating for our traps, we also had 3 control trees per plot, at least. If it was a double set of 18 total Tree of Heaven with traps on them, we had 6 control trees. So for all these studies, we had 39 control trees. And again, we looked at how many eggs were and just adjacent, just Tree of Heaven that was just near where we had put our traps, similar size. And we had 39 trees total from the base up to the tent for all 39 trees was 52 egg masses. So not much. We're really concentrating our eggs within here. So for the non-preferred host trees, much smaller numbers. So these again are present within our plots. And we just instructed if you have some maple trees or black walnut or cherry, just go ahead and throw some traps on there and let's see how they produce. So you can see this is our Tree of Heaven. We had a total of 126 of those. Average for just Tree of Heaven was 52 per trap. The black cherry there was no statistical difference here, but I would say if you have one of these non-preferred host trees, black cherry would probably be an ideal pick to put these traps on. Walnut performed okay. So just to summarize then, expect between 30 and 50 egg masses per trap in areas where you have decent populations of lanternfly. We had a couple traps, one was close to 300, just huge numbers. And they would just cluster their eggs and just lay on top of each other, the egg masses on top of each other. I would say that black cherry is probably best as far as a non-preferred from what we tested. And also, if we're doing visual surveys for egg masses, I think if you're putting out a lampshade trap, it's going to beat any kind of visual estimation that you're doing. And the reason for that is, again, that we had our at least 3 control trees per plot. There were no traps on that tree, so we just looked at how many egg masses were on those control trees from the base up to 10 feet. The average is 1.3 egg masses per tree. And that was from the data of 52 egg masses on our 39 control trees. As opposed to that, we had 155 traps on Tree of Heaven or these other species, and we had over 7,000 egg masses. So if you're out there scraping and think about what numbers you're scraping, you could put out these traps and probably take a lot more egg masses out of the environment than by scraping. So uses, certainly, research needs, like if we need individual egg masses for the colonies, there's certainly an option. I also feel it's has a lot of benefit for early detection, and then this trap and remove aspect that I was just talking about. Also delimitation, if you have some of these new states and you're worried about surrounding areas, you could look at this, we can always look at nymphs and adults with the circle traps or some of the other traps. But this is just another life stage that we're not really looking at, especially with these traps, since it's concentrating them. Another area I'm interested in is just possibly using the trap as a means to calibrate or assess how good are our treatments in the plots that we're treating. How effective are we? Are there a lot of eggs still being produced in those plots? So this is a red tail hawk, this poor thing. Melissa, she's a birder. So this is from some birding group in Pennsylvania. And there's one on his back. There's a bunch on his feet, on the beak. And sometimes we get little visitors in our traps. But anyway, I'm happy to take any questions.
Cool, a lot of work. So thanks.
Yeah, sure.
So question, did you or could you, like with the data coming in, look at like on a given tree, what proportion are in the trap versus elsewhere on the tree? Because like, I don't know if you could let Holly speak to that, because we had a lot elsewhere, like in sycamore.
Right,
But
right.
because then if you looked at that, like that might be a fair count of control in terms of like proportion. But then also it would be interesting to see if like outside of that, do you have the incomplete egg mass covering outside, where if you're in the privacy of your tree trap, you might be fully covered. It might be neat to see,
Yeah,
what you're
I'd
getting
love
in
to
there.
look at, how many eggs are being produced up above that, or even at different heights of these traps. So there's certainly a lot more work to do, but it is a passive trap. It's not catching them or stopping them. They just go in and out. That batting material keeps them from going through the trap, because as horrible bug it is, they're so easy to kill, right? They kill themselves. So they get stuck. If we didn't have that batting material at the top, they would crawl in there and get stuck and kill themselves. So, yeah.
So I had a quick question about your lampshade trap. It kind of reminds me, well, it's basically, I was kind of curious, what makes it attractive for the spotted lanternflies to crawl up in it? Is it like a temperature, coverage, or safety?
Yeah, good question. So when we set out the same traps that horizontally, we would see them crawling in and out, but they just were not induced to lay their eggs. Lanternflies will always be crawling up and down anyway. So I think it's just the environment. So Dana, you were saying, well, where's our attractive mixture or whatever it is? Maybe they're just physical insects, right? They like to move around. They like to interact with each other, be close to each other. And here's an environment that kind of takes advantage of their behaviors. And I'm not an insect behavior person. I'm a pesticide guy, right? So I'd love to turn it over to other people and look at some of those questions, but I think it just creates an environment where they feel this is protected, like we see in other instances, undersides of limbs, these protected areas of the trees. And this, it's just like a super stimulus, I guess, for them to lay their eggs.
Hi.
Hi.
We put up about 5 of these traps this year and didn't have super great success. They were on red maple and they were really covered. We were having to pick the bugs off in order to put the trap up. It was like a full-time job, pick the bugs off so that you could not, staple them underneath and everything.
Okay.
But they didn't lay very many eggs on them and I don't know why.
Okay.
But I'd be happy to share those data with you
Sure.
and maybe put traps up again this year because it's a
So
highly
it's on red
infested area.
maple.
Red maple
Mhm.
in Pittsburgh. Yeah.
Okay, yeah, and we didn't put any of our other species. We didn't look at red maple. We just didn't have any in our plots. But I think there's going to be a lot of variation. But I think if you're putting it in Tree of Heaven, I don't know. That's a great question. I don't know why they wouldn't lay at least like we average, say 10 or so for the silver maple and the walnut. Were you getting that many? 3 to 5? Okay. Right. No, definitely Tree of Heaven they prefer, and this is the first time where I've put the traps up on other species. So yeah, we'll add that to the data. Maybe red maples even poorer on the list. Yeah, good question. Well, thank you, everyone. Appreciate it.